Okay, I have another question here. Um, if you haven't attempted to answer this question, please just pause this video for a while and attempt to answer it. But now I'm going to show you on how to solve this question. Okay, we have a function here, x cubed over x squared minus 5x plus 6, and we want to express it in terms of a much simpler form like this: ax plus b plus c over x minus 2 and dx minus 3. A, B, and C and D are constants, and later on we want to integrate them to get the answer. The problem with this function, it is difficult to perform integration right off unless if we change it into this format first, and then the whole thing becomes a little bit simpler, much simpler indeed. Okay, let's do that now. So for A, let's solve for A first. This is what we have: fx equal to x cubed over x squared minus 5x plus 6. Okay, I want to fully factorize the denominator here, and I'm guessing that it should equal to x minus 2 and x minus 3, but let's do that. So x squared, though we should have x and x over here. Product of rule is 6, so that should be 2 and 3, because 2 times 3 is 6. And we have minus 5 here, that should be minus and minus here. That exactly the same as the denominator here, x minus 2 and x minus 3. Okay then, and we are ready to go and substitute, we are ready to go and solve for A, B, C, and D here. Let's do that. So that, this whole thing, yeah, x cubed over x minus 2 x minus 3, that should equal to ax plus b plus c over x minus 2 plus d x minus 3. Why are we going to do this? We are doing this so that we can compare the coefficients later, so that we can right away solve a, b, c, and d. Okay, the second step that we need to do is to multiply the whole thing here by x minus 2 x minus 3. The reason is that we want to get rid of the denominator on the left side of the equation, the left side of the equal sign here, so that will yield x cubed on the left, so that equals to a, and then we have x here, and then this whole expression again, that is also the same as x squared minus 5x plus 6. Okay, the expression before we factorize, plus b, and again with this polynomial, x squared plus 5x plus 6, and then plus c. Okay, now as we have c, let's put it here first. C over x minus 2, that is multiplied by x minus 2 and x minus 3. As you can see, we have common terms there that we can just cancel off and leave c x minus 3. So I'm going to put that as c x minus 3. And then finally, we want to multiply this thing likewise with by d over x minus 3, d x minus 3. If we multiply that by x minus 2 and x minus 3, as you can see, this cancels off. So we have dx minus 2. Okay, I'm gonna delete these things here so that I can create more rooms. I don't think I have enough rooms. I might need to prepare a second page for this. Again, we expand this, yeah. So x cubed equal to a, let's just expand it all together, ax cubed, yeah, x times x squared is x cubed minus 5ax squared, and then plus 6ax plus bx squared minus 5bx plus 6b. Okay, next is c plus cx minus 3c plus dx minus 2d. Okay, I hope I get everything right. Let me just check. I think so, yeah. And this is also correct. This is correct. This is correct. I hope so, yeah. So x cubed here. Let me retain it there. Then let's group all the like terms here. First, the coefficient of x cubed here. How many x cubed are there in this lengthy expression on the right side of the equal sign? We have 1 here, and what is the next x cubed? There is none. Okay, so that is only ax cubed. All right, now let's gather all the x squared terms. Okay, we have 1 here. So let's just put plus minus 5a. All right, the next one is here, bx squared. So I just put plus b. Oh, let's not close the bracket just yet. I want to inspect more x squared terms here. Is there any more? Looks like we are done. Yeah, x squared. So we have already completed this, and this. Let's take a look at the terms containing x only. Plus, okay, 6ax, yeah, 6a. Okay, that's done. Let's cut it out. And then minus bx, minus 5b. Next is cx. Okay, yes, don't forget to cut out so that you remember what you've done. Minus 5b, and then plus c, and then plus d, yeah. Okay, cut out minus plus cx, and then dx, yeah. So plus d, close bracket, x here. And then the terms without any x, that is 6b, 6, cut out here, minus 3c, minus 3c, and then minus 2d. I think we have done everything. We have captured everything here. Okay, now let's compare the coefficients of all the terms on the left hand side and the right hand side. Okay, as you can see, the left hand side of the equal sign, there is only one term, which is x cubed, and the coefficient of x cubed is equal to 1. So that makes a equal to 1. So let's put it up here. A is equal to 1. Okay, that's the first solution that we've got. Next, the coefficient of x squared, minus 5a plus b. And remember, a is now equal to 1. And there is no x squared over on the left, which means to say minus 5a plus b. That should equal to 0. And remember that a is equal to 1, so let's just rub it off. That makes it that b is equal to 5. So let's update. Let's update here. B is equal to 5. Okay, next. Let's take a look at the coefficient of x here, which is 6a minus 5b plus c plus d. That should also equal to 0, because over on the left side there is no term containing x only, yeah. And the value of a is 1, so let's just take it out. And value of b is 5, so that is 5 times 5, that is equal to 25. Okay, so 6 minus 25 is minus 19. Yes, so that means c plus d is equal to 19. Okay, that I call that equation 1. And I believe that we are going to solve simultaneous equation here to find C and D. Let's take a look at the last term here. 6 minus 3C minus 2D. That should also equal to 0. I'm putting a different color now. So that is 6 minus 3C minus 2D equal to 0. Right. Well, you know what? I think I made a mistake here. This is not 6, but it's actually 6B. Yes. Yes, 6B and minus 3C minus 2D. So let's get that corrected here. Okay, solution like this, you tend to make some mistakes because of the length of the solutions here. So this is 6B. 6B then. But B is equal to 5. So 5 times 6, that equals 30. So let's just put right there. Which means to say that 3C plus 2D is equal to 30. And I call this equation 2. And we have two equations here involving C and D. So we can solve simultaneous equation to find the value of C and D. I'm gonna take equation 1, that C, I'm putting D. I think I'm putting D over on the left side. D is equal to 19 minus C. And we are gonna put this into 2. Into equation 2. Let's do that. So 3C plus 2D. D is now 19 minus C equal to 30. So 3C plus 2 times 19, that is 38 minus C. Minus C, not minus C, but minus 2C is equal to 30. Okay. 3C minus 2C, that equal to C, equal to 30 minus 38 minus 8 then. So C is equal to minus 8. C is equal to minus 8. So now what about D? D is equal to 19 minus C. So that is 19 minus 8. So that is plus 8. That is equal to 27. Yes, 27. So D is equal to 27. Alright, now, so we have found the value of A, B, C, and D. So that settles question A. So we are going to do question B on the next screen. Okay, here we are again. We have already found the value of A, B, C, and D. So let's put it here. Just put it at the corner here. A is equal to 1, B is equal to 5, C is equal to, what's the value for C? Minus 8. Yes, minus 8. Minus 8, and D is equal to 27. Okay, minus C, that is correct, 27. Okay, so fx now is equal to ax, or just put x, plus b plus 5 plus c. I'll put minus then because c is minus 8. So minus 8 over x minus 2 plus 27 over x minus 3. We are going to perform question B. We have to answer question B by performing integration of fx. Okay, it's not easy or almost impossible. Well, at least I do not know how to integrate this expression. Okay, unless if we put that into this format here. Alright, then it becomes somewhat easier. So, boundary condition 6 and 4. This is a definite integral fx, and with respect to x, that is equal to boundary condition 6, 4, and this whole expression here. Okay, x minus 5 minus 8 over x minus 2 plus 27 x minus 3. Okay, the first two terms here are linear terms, so that's easy to solve. So I'm going to separate them out into this. Yeah, I'm just going to put separate x minus x plus 5 here, because this one is easy. And then do this the last two terms separately. This is basically minus 8 over x minus 2 dx, and then plus 27 over x minus 3 dx. Okay, the first integral is quite easy to solve. That is equal to x over x to the power 2 over 2 plus 5x. Okay, that's right, x a bit more, it's a bit better. Okay, between 6 and 4. And the next one here, this is a bit challenging, but if you have learned integral of reciprocal function, then you know that if you have something in the form of f prime x and over fx, okay, this should be natural log of absolute value of fx. Okay, this integration of derivative of fx over fx itself, that should equal to natural log or ln of absolute value of fx. So if you look at this, okay, we can, well, it is not exactly the derivative of x minus 2, but 1 is. So what we can do is that we can modify this equation by putting 8 outside here. I'm putting 8 here, and then replace that by 1. Then I have fulfilled this criteria here, right? 1 is indeed the derivative of x minus 2. Okay, so now I have the answer for the second term, that is equal to minus 8 natural log of x minus 2. Okay, that settles the second term, or the third term indeed. And we have another one here to do. Oh yeah, the boundary condition 6 and 4 here need to put. Okay, now again, we put 27 outside here, so that let me just put a different color, yeah. And to create room here, let's just put it nearer, and different color here, plus 27, and I replace that with 1 here. So now that is plus 27 natural log of absolute value of x minus 3 between 6 and 4. All right, now then let's put in the value of 6 and 4 to solve it. So that is equal to 6 squared over 2 plus 5 times 6 minus, okay, square bracket here, yeah, 4 squared over 2 plus 5 times 4. Okay, this is gonna be some lengthy work on this. Okay, that is a natural log of 6 minus 2 is 4. This should be absolute value of 4, but 4 and absolute value of 4 is exactly the same thing. And minus 4 minus 2, that is ln 2. Okay, and then plus 27. Natural log of x minus 3, natural log of 6 minus 3, that is 3. And then natural log of 4 minus 3, which is 1. Okay. Again, we don't have enough space. We'll try to squeeze it later on. So over here we have 6 squared 36, 6 36 is 18. 36/2 is 18 plus 30, that is 48. Okay, I hope I do not make any mistake. Okay, correct. 18, 30, 48, correct, yes. Minus 4 squared is 16, 16/2 is 8. 8 times 20, 28. Okay, minus 8. Okay, ln 4 and ln 2. Okay, let's put it here. Ln 4 minus ln 2. We can put 4 to become like this, yeah? Natural log of 2 squared minus natural log of 2. And according to index logarithm rule, this equal to 2 natural log of 2 minus natural log of 2. So essentially the whole thing, 2 minus 1 is equal to ln 2. Okay, so this is ln 2 plus 27. Okay, what is ln 1? Ln 1, that should equal to 0, because e to the power of 0 is equal to 1. Okay, so that is ln 3 then, natural log of 3. Natural log of 3. Okay, I am going to delete everything here because I'm going to squeeze the remaining answer at the top here. All right, I'm gonna draw some weird looking line here to separate it. Okay, 48 minus 28, that is 20. Minus 8 natural log 2 plus 27 natural log 3. Is that the last thing? Is that the final, most simplified answer to it? I think so, yeah. I think so. So that's the whole answer for this question. Did I make any mistake? I hope not. Okay, but if you do notice that I made any mistake, please comment in the comment section. Please leave a comment in the comment section so that we acknowledge any mistake that we've done. If you like this video, please subscribe to this channel and share it as much as possible with your friends so that everyone will get benefit from this video. Yeah. Okay, hope to see you again. Bye bye.